Hello, CWIEME community. Welcome to CWIEME Talks. I'm Alexandra, and I'm delighted to welcome Gianmarco Pisanelli, Technical Fellow at Robotics Research at University of Sheffield-AMRC. Welcome, Gianmarco. Thank you for joining us today.
Thank you for having me.
Let's start talking about your background. What led you to pursue a career in robotics?
Sure, yeah. I think it came a bit naturally because I always had a passion for engineering in general, and I wasn't quite sure where to start and where to look at. So when I came across robotics, I realized there was a mixture of a multitude of subjects, which sounded perfect for me because I didn't know exactly how to specialize in one specific subject. In fact, robotics is sort of a mixture of electrical engineering, control engineering, mechanical engineering. There's also a bit of software engineering, and I quite liked how it all came together. The sort of one of the best sort of feeling that I had when I started working in robotics was having that sort of feeling of starting to see something move as a result of a bit of code put together, a bit of wiring, and a bit of sort of things that link together. And having that sort of satisfaction, of immediate satisfaction of having something moving, was just what made me fall in love with robotics.
The AMRC is known for its groundbreaking work in manufacturing and robotics. Could you share with us some of the exciting projects we are currently working on and how they are pushing the boundaries of robotics in the industry?
Sure, yeah. So at the AMRC, what we tend to do is we sort of act like a bridge, or that sort of tries to close the gap between research that happens at university and what industry needs. So what we do is we look closely at what research is happening at the university, and we're trying to see how we can push those boundaries towards the higher technology readiness level. As part of that, in fact, we work very closely with Sheffield Robotics, for which I'm the core team lead in manufacturing. And we supervise students, we also go and attend conferences, and we publish papers as well, just to understand what the state of the art is in research. And then we have quite a lot of contacts with specific companies that range from very small SMEs to very large conglomerates like Boeing, Airbus, and so on. Some of the projects we're working on are quite specific, so they're sort of confidential, but we also work on projects that are funded by the government, that are where the IP and the outcomes are open to the whole of the UK. Some examples are sort of works that look at how can robotics can be made more simpler and more accessible to everyone, because at the moment using robots is very complicated and you need quite a lot of training. So we try to make robots more intuitive and more simpler to use. We also look at how can we use robots in realm and fields that have never been used before, learning from experiences from the past. One of the projects that we're currently working on is on robotic disassembly. Sustainability is quite a big sort of focus of the work that we do at the AMRC, and as well as sort of trying to design for disassembly to make everything simpler to be disassembled and then recycled or remanufactured. We also look at how can we take things apart that are currently already in the market and need to be recycled. So what we're doing, and this project is in collaboration with the Fraunhofer IFF, we are looking at ways of having robots coming into contact with objects that they haven't seen before, or they're like quite complicated to use. And we sort of teach the robot in a very human way how to disassemble the part. This is something that we've created a framework where the robot can understand human instructions, and an operator can first get the object, inspect it, take it apart on his own, and then understand all the different steps, and then communicate that to the robot in a very human language. And then from there on, the robot will be able to disassemble any other objects that either identical or similar shape.
Well, it's fascinating to hear how robotics is advancing in these practical ways, namely on robotic disassemble. What do you think are some of the biggest trends shaping the future of robotics, especially in the context of manufacturing?
Yeah, I think it's not surprising that one of the biggest trends involves AI, because AI is affecting literally everyone and everyday life. So, and robotics and AI are quite closely related, because there's a lot of AI that's already been used for years in robotics for motion planning, for the kinematics, and for sort of content-rich tasks for robotics. But now what sort of seems to be becoming a trend is the use of general purpose AI, which are models like ChatGPT that we're all aware of. And this type of models are trying to be used to simplify the ways that robots are used. As I mentioned before, robots are quite complicated to use and you need quite a lot of training. But the use of AI could simplify the use of robots so that everyone can start using them. We've got a big gap big skill gap of engineers, and there's especially the UK sort of trailing a bit behind when it comes to robotics adoption. And one way to sort of bridge this gap could be the one of having these models where they comprehend human sort of natural speech, human language, and they make it possible to just speak to a robot, give it a task, and the robot automatically performs it without having an experienced programmer to actually start programming the robot and spending months and months in programming the robot.
You mentioned collaborative robots. Could you explain more about how these robots work alongside humans and what benefits they bring to the manufacturing environment?
Yes. So collaborative robots have been around for about 10 years now, and you can see them quite a lot in industry. The main reason why these robots have been brought to the assembly line is that they are safer to use around humans. Generally, when you see assembly lines that use robots, they are sort of caged to protect the humans, because these robots are quite big. They move quite fast, and if they come into contact with humans, they can seriously injure them or even kill them. These new collaborative robots instead are built to sort of have a safe human-robot interaction, so all the cages, all the barriers can be removed, and robots and humans can work in the same environments and share the same environment. Now, this is advantageous because robots are very good at doing repetitive tasks and work around a constrained environment. But when it comes to something that's a bit more complicated or that the robot hasn't met before, these robots really struggle and they don't know how to handle that. So having robots and humans working together in the same environment can sort of leverage the problem-solving nature of humans, which is something that we are really good at, and then use the physical ability of robots and the sort of strength and speed of robots, and to do tasks in a much more reliable and much more efficient way than we can do.